Good afternoon, teacher. My name is Jose Pereira. I am the leader of 7 group. Today, I will talk about the topic process, action, and sequence in electrical engineering. Introduction: Electrical engineering is one of the most essential and dynamic fields of energies, dealing with the study, design, and application of electrical systems and equipment. From generating power to transmitting signals, electrical engineers are responsible for a wide range of processes that require clear action and well-structured sequence. Understanding this process helps professionals maintain safe, efficient, and effective their work. This paper explores the various action and sequence common as in electrical engineering. Electrical engineering process. Electrical engineering involves numerous processes depending of the subfield. These may include power generation and distribution circuit design, control system, science, processing, and electronics development. Each of these areas requires professionals to follow systematic sequence to achieve their goals. For example, design a circuit board involves several steps: analyzing requirements, drawing schematic, simulating the circuit, just components, create a PCBA layout, fabricating the board, and testing it. Each step must follow a logical order to ensure success. Missing or missorting steps can lead to failure or safety risk. Process, Processes can be manual or automated. Automation often involves programming microcontrollers or using software to simulate or control system. Electrical engineers must not only understand how things work, but also how to assemble and troubleshoot that as structured procedures. Common action electrical work. In electrical engineering, specific actions are performed repeatedly. Some of the most common actions include installing components like switches, fuses, breakers, or cables, measuring voltage, current resistance, or frequency using multimeters or oscilloscopes, connecting wire, connecting wire and device, ensuring proper insulation and polarity, testing circuits for continuity, load balance and circuit compliance, repairing or replacing damaged or failed components, program microcontrollers and digital systems, troubleshooting as in diagnostic tools and procedures. These actions are typically described as the present simple or imperative form in technical documentation. For example, measure the voltage across the terminals or connect the ground while first. And understanding these verbs and their function is key for communication and workflow in way engineering environments. Step-by-step sequencing projects. Every electrical engineering task usually follows a sequence. A sequence is a logical or an action required to complete a process safely and successful. Below is common sequence followed during the installation of a sample electrical system. First, plan the circuit, define objective load requirements and circuit features. Second, get materials, wires, circuit breakers, circuit connectors, and tools. Third, turn off power sample. Circuit is the step priority. Fourth, lay out the rate, wiring, marking paths for the cable installation conduits. Connect 5. Connect components, install heartless switches and fixtures. 6. Connect to the main power. Link the system to the power source. 7. Test the circuit. Check for proper function and safety. 8. Finalize installation, secure components, and document the work. Each step must be executed in sequence. Skipping or wrong steps may lead to equipment damage or personal injury. Case study. Weighing a residential circuit. To illustrate this concept, let's consider a basic residential wiring project for lighting and power outlets. First, the engineer assesses the house layout, calculating the number of outlets and lights needed. Then he draws a range diagram showing all connection. After approval, the installation begins by running cables, trucks, conduits in the holes. Switches and sockets are mounted in the appropriate place. Next, the wires are connected to distribution panel and breakers are installed before entering the circuit. Hall connection. Hall connection, the circuit for continuity and grounding. Once verified, the power is turned on and tested are performed to ensure everything operates correctly. This case demonstrates the critical importance of following an action sequence to avoid hazard and assert proper function. Thank you very much for your attention, teacher.